In this lesson, we are going to look at a very important data structure, namely the tree. In fact, trees are almost as important as lists. And calculating with trees brings in many new interesting ideas, such as organizing data for efficiency, such as putting global conditions on data structures, goal-oriented programming, and also the notion of logarithmic efficiency, where looking up or doing something with n items takes a time proportional to the logarithm of n, which is a much smaller number. So a tree is a recursive data structure. It's either an empty node or a set of subtrees. Let me bring in a diagram here. So the empty tree, so here we define a tree whose element nodes are of type T. The tree is either a leaf, which is an empty tree, or it's a non-empty tree, which here consists of a root node and a number of subtrees. The root node has a piece of information with type T, and then it has a number of subtrees which might be empty. So let me show you an example of this. So T100. So here I have a tree where each level has 3 possible branches. Oops, I'm missing one here. There we go. So we can display this. So for example, if I do browse T, I get here on the browser window, I can see the values. Notice that I've written the tree as a nested record, but that I did not put in the field names. If I don't put in field names, then Oz will automatically give me field names, starting with 1, the integer 1, and numbering consecutively upward. So for example, in this case, T.1 will be 100, the first element of the record. T.2 will be the second one, which is the first subtree. T.3 will be the third one, which is in fact the second subtree, and T.4 will be the final subtree, which in this case is leaf. So notice here I have therefore a tree that has 3 branches at each level, and when it stops I have leaf showing that the tree does not continue. If I want to access one of the innermost nodes, for example the 10 value here, I have to go down the tree like a path. I have to first take the first subtree of T and then take the first element of that subtree. So if I want to access the 10, I have to do something like this. T.2, which gives me the first subtree, .1, which gives me the first element, which gives me 10. So you can see the 10 here. So this tree has 3 branches at each level. The number of branches can vary. In fact, let me compare trees with lists, because lists are actually a special case of trees. So here we have a tree definition, and I put it next to the list definition. So the tree is either a leaf or a non-leaf node with a value and a set of subtrees. A list here is either nil or T followed by bar followed by list T. Notice the difference here. A list has at each recursive level 1 sublist. So it's a linear structure. It's a line. Whereas a tree at each level can have more than 1 subtrees. So it has a branching, bifurcating structure. And it depends on how many subtrees there are. So the difference of having just 1 subtree here or having more than 1 is an enormous difference, and it will make for a whole new set of programming techniques.